We're gonna get started. So, hi everyone. My name is Fernando. I don't know how many of you know me already. I'm a PhD student at UPenn at the University of Pennsylvania, and I'm here presenting work that we have done with some colleagues and ex-colleagues from UPenn in open source nano-UAVs. First of all, before starting my talk, I would like to thank the organizers of the Developer Summit, because honestly, it has been a great space to interact with other people from the industry, with other people from academia working with UAVs, and I think it has been an amazing conference. So let me start with a simple question. Why do we care about nano-UAVs? What are the applications that you target for these small drones? The first one is like nano-UAVs are important and useful for research and development and also for commercial applications, because they are inherently safe. They have less inertia, they have smaller props, and that translates into hurting yourself less, which is great. I usually fly on top of these small drones. I fly a drone that is 9 pounds, 4.2 kilos approximately, and has 15-inch props, and that thing is really scary and can hurt you really bad. So small drones are always good for that. Small drones are also more resilient, because I have a little clip here that I want to show up. So you see in this clip, we have bees that are bouncing around while they're flying, and they can still sustain flight. And the reason why these bees can do this is because of their size. The smaller you go, you will be able to bounce on obstacles, and you will be able to recover from these bounces without crashing your drone. But if you end up crashing, having less mass is always beneficial. So you don't damage your drone as much if your drone doesn't weigh too much. Also, I would like to argue that scalability on swarms require small platforms. So this is a video that Ramon showed in his talk at Roscon, and I find that is amazing too. It's one of the works that Brown by Nora Ajanian's group, where they are flying multiple small UAVs in a synchronized way, forming a swarm. And if you have a big drone, you won't be able to do this kind of applications unless you have a big open space, as we saw last night. And finally, we have the 250-gram limit. Which, if you go today to the FAA website, you will see this small note that says that if your drone is more than 250 grams and you're using it for recreational applications, you'll have to register it. And now that also means that you will have to have an ID on your drone. So you can avoid this burden if you're using your drones for recreational applications or research if it's less than 250 grams. So I hope I convinced you why nano-UAVs are something that is useful, but I would like to focus a little bit more on some applications and potentials of this technology. First one, the one that we always know, surveillance. This is the Amazon Ring Always Home. I checked last night and it was still in their Amazon early product webpage. It's some kind of like crowdsourcing, but from Amazon. So you can pre-buy the product and you will get it when it's done. For those of you who don't know what this little drone does, it's a security camera that can fly and take pictures or videos from a different angle compared to static security cameras, which may be useful. I don't know. I think that these kind of things are important, and that having something that can move and give you a different point of view is really important. And this is particularly important for law enforcement. This little guy here is quite small, this size, but it costs a lot of money. As far as I know, these drones are going to start being deployed. This is more like an RC helicopter that is deployed with the goal is to have an early access to buildings or to confined spaces without endangering people. we have the inspection applications. So I don't know if you know this company is called Cleo, and the drone is called Dronat. I don't know who came up with the name, but they deserve a rise. So this little drone is based on the Model AI voxel platform and can bounce off obstacles, inspecting narrow sites where quads can get their props entangled and can crash. So these are some of the applications that we're looking for these small quads, but also search and rescue. I know that this is something that we talk a lot, but I would like to show a concrete example where nano-UAVs can help. So this accident occurred in East Carbon City in Utah. There was a fire, and for those of you who are not very familiar how firefighters act, when there is an emergency. I'm not a firefighter myself, but I have a friend who has told me how it works. They have to go through some safety checks before entering a property because they have to ensure that their safety is not guaranteed, but at least try to minimize the potential risk that they face. And it turned out that in this case, they didn't know that there was somebody in the house. They thought that the house was empty. And this end up with a casualty in this situation. So wouldn't it be amazing to have a drone that we can deploy and can tell us if there are victims in the house that maybe are unconscious because of they have been like in this situation for a long time, but it will be good to know if there is somebody in that property before firefighters or emergency responders can access. So what are the solutions that are available currently on the market? The first one is the Crazy Fly. I'm pretty sure most of you know this little platform. And I have to say that one of the big wins of the Crazy Fly is that it democratized access to UAVs for a lot of research groups in universities. It's inexpensive. It's very simple. Brush motors, simple flight controller, which is good for drones and quads that are sometimes very complex machines that can have a lot of moving parts. You can expand it with decks depending on your needs. So two of my favorite ones are the AI deck that has a little AI accelerator that you can use for different AI applications, detections, classifications, and so on. Positioning deck with ultra-wideband. But the Crazy Fly has a couple of disadvantages. The first one is the restricted payload capacity. That is approximately 15 grams. The second one is that there is no companion computer on board. So if you want to implement some autonomy algorithms, you have to put them in the small microcontroller that the Crazy Fly has. And that gets quite challenging fast. And the third one is that there is no PX4 by default. The flight controller that is running on these guys is a different one. I was checking there are some efforts to migrate PX4 into the Crazy Fly, but still it's not the default flight controller. We have Model AI that the research group I'm in has worked before. For those of you who are not familiar, I don't know if we have somebody from Model AI in the room. Okay. These platforms are the inception of what was the Starlink afterwards. So this was research work that was done in the university with the goal of trying to minimize the size of UAVs. And they came up with these different platforms that we can see in the image, Dragonfly and Starlink V1. So this year's the Starlink V1 that was the origin of these very small UAVs with onboard compute capabilities. Then recently Model AI released the Voxel 2 board, which has quite a lot of compute, AI engines, onboard flight controller, and VIO. It's a pretty nice piece of hardware. And based on this board, they released the Starlink quad that we saw in the presentation yesterday, on top of their development kit. So this nice piece, very nice piece of hardware has time of flight sensors, a global shutter tracking camera for VIO, high resolution camera, and GPS. Total weight without batteries is 175 grams, 175 grams. goes to 275 grams with batteries, so a little bit over the threshold that we're targeting. But the issues with Model AI is that if you have worked with the platform, it's a great ecosystem, and they're putting a lot of efforts to create a lot of good tools. But Qualcomm provides the hardware is closed, so there is nothing that you can do if you want to modify some of the lower parts of your system. You have to run with whatever they are giving you. That makes that the platform is difficult to hack. So there is so much you can do if you want to modify or access some of the low-level components of this board. So to answer these solutions, that we think that there is a need for a platform that is something in between the complexity of the Starling V2 and the Crazy Fly, we are releasing the P65. So I have it here on my hand. This is the platform, and you can see it here. Oh, I think it's darker than on my screen. Hopefully you will be able to see it. Good. So this is the platform that is currently flying in manual mode in those videos. You can see that it's very small. It's 85 grams. And making it small is great because it can fit in very narrow spaces. It features an IMX8M Mini processor on board. And also we have a PX4 flight controller with an AI chip to do inference on board. It can run both in indoor and outdoor settings, as you may see in this clip. It's quite stable in windy conditions. I'm quite impressed with the performance. The platform can run with batteries 1S to 3S, which I think is very interesting because you can fly it with LiPos if you want higher thrust-to-weight ratio, or you can just use a single 18650 cell, as some of the FPV tiny whoops do. And our flight time is approximately 5 minutes, but you can get longer if you use more capacity 18650s. So to recap, the characteristics of the quad are the following. Lightweight, 85 grams without battery. And for reference, this 18650 battery is 50 grams. So that gives you an idea of how lightweight the platform is. Size is 8 centimeters by 8 centimeters by around 5 centimeters high. PX4 base from the get-go, targeting both autonomous and semi-autonomous flight. Battery support from 1S to 3S, approximately 5 minutes flight time, depends on the battery. But this is important because you can put a battery that has more, a longer capacity for a longer flight time, or you can put a battery that has a lot of power if you want to have a high thrust-to-weight ratio. Quad-core ARM Cortex-A53, 1.8 gigahertz. Something that is important is that as the system model that is on the top of the quad is a module, we can change it when there is a better option in the market. So this is something that is very cool about the platform. Different communication modules, XB, ZigBee, Wi-Fi, Bluetooth. We were discussing yesterday with NXP on what else can we put on the platform. We have discrete place in the PCB, so changing the flight controller can give you different communications capabilities depending on what you need. Hardware accelerator on board, and we have a TPU that is able of 4 tera operations per second for different inference tasks. So system architecture for those of you who do UAVs is pretty similar to what you're used to. Is only very optimized to fit in this reduced size. We have our ESCs, our in-house ESCs that we designed ourselves to be able to fit in the narrow space that we have. And they can work both with D-Shot and PWM. The flight controller, as I mentioned, is something that we designed from the ground up. So we base our flight controller on the FMUV4, but we're looking into improving for the FMUV6. Different communication modules, as I mentioned. a TPU for inference on board, and all these components are on the flight controller board that you can swap. Then we have the main board where the different ESCs are attached, and also where the system on module is attached. And we have 2 data ports, a high resolution camera port that has 4 lanes MIPI CSI plus SPI. And we also have the general payload sensor port that is I'm going to mention later in my presentation. So I know this guy is small, so I put it in big there for all of you. So on the bottom, you see the flight controller board that I mentioned with the different components, TPU and communication module. On the top, there is the system on module, and ESCs are distributed in the 2 sides of the board. We also went to this with this design instead of doing a single board for the 4 ESCs, because we wanted to be resilient to, for instance, if one of the ESCs fails and we want to change it later, you don't have to change the whole board. Or if you want to update the ESCs without updating the whole board, you can do it. So detail about the system on module. This is the IMX8 Mini from NXP. I saw a picture where they were comparing, I think, one of the Model AI chips with an Oreo. So this is the chip that we're putting in our quad, the system module, compared to a quarter. So you can see how big it is. These are the characteristics. It's only 7 grams, and it has an M4 coprocessor. It would be great to be able to run PX4 directly in that coprocessor instead of using a discrete flight controller, but this is something that is going to take some effort to get working. The most important part about this chip is that it has very good documentation. You can go right now to the internet and access most of the documentation for this chip without requiring to sign any NDA. So the $5,000 of documentation are available. And that is why this is one of the most used chips for a lot of open source projects, because it gives you this flexibility that a lot of the more closed source companies don't give you. We are able to build our system using Yocto, and we're also able to grab a root file system from, for instance, Ubuntu, and put it together. So once you have Ubuntu on your board, that enables you to install ROS and run ROS in this little quad. That is something that we're targeting from the beginning. Have a ROS-enabled platform that has the size of a Crazy Fly, slightly bigger, but is able to run all the compute on board. The flight controller was an in-house design, as I mentioned before. Right now it's an FMUV V4. We're looking into improving to the FMUV V6. The sensor stack is pretty standard: 2 IMUs, magnetometer, barometer, and a time of flight sensor for altitude. Some of you were asking me if we are looking to put an optical flow sensor, and the answer is it may be a bit difficult, but I will get back to that question later. And something that was very useful for us is to mount the sensor stack of the flight controller in a soft-mounted sensor plate. This is because for these very small platforms, vibrations are quite tricky. So we had some discussions with some people from Ojeda yesterday. They told me that this may not be the right approach. In our experience, this is one of the keys for enabling stable flight in these very small platforms where you don't have the luxury of adding carbon fiber bars to increase the rigidity of your platform. But vibrations was a big part of the design. We did a lot of simulations to estimate the different vibrational modes of the quad and what modifications we had to do in the hardware to minimize the vibrations, as you can see in these figures. And I would like to say that this is the only place I can brag about these plots. Nobody else would understand them, but like the vibrations that we're seeing in the platform are quite small, which shows how good this design is. For the sensors and the camera interface, we have the 4 MIPI CSI lanes that enable you to use different high bandwidth sensors. We have a working high resolution RGB sensor working on the platform. We're working on a global shutter and a time of flight sensor that I would like to mount on this port. But we also attached an SPI data port next to the camera port, so we're able to get our own VIO sensor. It's this little guy that has an IMU directly attached to the camera, attached and synchronized to the camera. And for the low speed interface is another port that we have on the back of the quad and has three interfaces, SPI, I2C, and SAI. Do you know what SAI is? Okay, it's serial audio interface. So this enables you to have either microphones or speakers in your little modules that you're attaching to this port. And it provides voltage. So the idea is that the end user, if they want, they will be able to design little PCBs to attach to this module. Similar to what other electronics companies are doing with these general ports that you can attach different sensors to them. And we have designed modules for thermal cameras, for general GPIO plus ADC for the different, if the user wants to do data acquisition, they can use this module. LEDs, a motor controller, GPS, and these are I would say, the two most interesting sensors. VOC measures volatile organic compounds. So it's a sensor that can detect, for instance, human presence in a room. And also a speaker and a microphone. So if you want to listen to audio or record audio in the platform and broadcast it, or if you want to use it as a speaker, you can do it. Somebody asked me, like, you will not hear anything if the quad is flying and you're trying to record. And I think that is a fair point. But you may either land or you may try to filter the noise of the platform. So what is the status of our platform? We have developed this since 2021, 2020. We have done 12 hardware design changes. 3 versions have been manufactured. This is the 3rd version. And we have 3 high-resolution sensors, as I showed. One of them is designed and tested. The other ones are designed and being manufactured, plus 10 general-purpose sensors. And right now, a lot of people are asking me when they can buy this platform. And unfortunately, I don't have a strong answer for that question. We're going to start releasing the pinouts and simplified schematics because people are interested to see what the platform can do. But we're looking either for a manufacturing partner or to get enough funds to do our first manufacturing run. But I need your help. If you can help me and go to that link and fill out this quick poll, this will help us a lot to measure the interest that people have in this platform and measure what is the potential cost of the platform that we can, how much we can charge for the platform, and project how much, if somebody wants to invest, how much money we can get in return. So if you can fill out that form, in exchange I may do a flight. They told me I can't, but I'm going to ask for forgiveness afterwards. So please fill out this form, and I will see you in a minute.
Telemetry covered.
Good luck, Mike, getting this on focus, though. So right now we're flying with a 2X battery. But if you guys are interested, we can do flights with the 1S lithium-ion cell afterwards. The quad feels a little bit more heavy with the 1S, but the flight time is longer. And if you're PX4 users, you heard all the noises when the flight controller started, so I'm not lying about it. Yes. All right, so I'm glad that did go well. So if you guys have any questions, please feel free. Sorry? To Philadelphia, Pennsylvania. I will give my address afterwards. Any questions? Right now? So just before the conference, if you guys saw the video where I put the 1S to 2S, I was measuring, I wanted to measure exactly that. And I measured about 5 minutes. But the day I was recording outside and it was quite windy. So I have seen up to 8 minutes when I'm flying indoor with any wind, like just hovering. We're working on improving this. It gets tricky because as we are very small, the size of the props is small, and that usually affects your efficiency. Bigger props are always better for efficiency. Your quad is less agile, but they're better for efficiency. Yes? So yeah, as I was mentioning, there are two options. Either you can run the Yocto toolchain that you have running on board, that we have running on board, or we are also offering this hybrid that you can grab the kernel from Yocto, put it in an Ubuntu environment, and that is pretty much Ubuntu. From there on, we haven't developed specific hardware, but you can run your traditional ROS tools. If you want to run MapROS, you can do it. But we don't have any specific hardware, any specific like tool chain, if that is your question. That's a good question. Not yet, but hopefully when the development continues, we'll be able to provide all that. Any other questions? All right. Thank you so much. And again, thank you so much for letting me present here. Thank you, Ramon. Thank you, all the organizers. And we can chat afterwards if you guys are interested, or if you want to fly it. I shouldn't be saying this, but if you want to fly it, we can fly it. Thank you.